Okay, a new study just debunked one of Albert Einstein's long-held theories involving quantum physics. But that's not all going on in the world of science. Austrian researchers recently discovered that ant colonies have a pretty remarkable way of fighting disease. Here for a closer look at these stories and more is Canada Research Chair at the University of Guelph, Merritt. Thanks so much for being here.
Thank you.
We're starting off with monarch butterflies. Researchers tracked them and learned amazing things about the butterflies. But how did they do that?
So I want to talk today all about the unique ways that we can measure connections in nature. And, so we know that some butterflies can migrate, but it's really difficult to study. So in this new research, scientists used pollen carried by butterflies. They picked tiny little pollen grains off of butterflies and then obtained DNA information from each pollen grain. So the pollen told us where the butterflies had flown from, and it turns out they had come all the way from Africa to Europe. So just like UPS, these butterflies are delivering little packages of pollen, but right across continents.
3,500 kilometers away.
So remarkable.
That's incredible. I know you think about tracking butterflies, it's not like you're putting like a tracker on the butterfly.
It's difficult.
You'd have to do it this way. Incredible. So let's talk about the ants. When there was something going wrong, like an outbreak of disease or something that could take out the whole colony, how did they react to it?
Yeah, so you'd think with all of the coming and going of worker ants that disease would spread really quickly through an ant colony.
And they're right close together. They're touching all the time, right?
So scientists introduced some worker ants to a deadly fungus and then discovered that the entire colony really quickly shifted its behavior. They sensed the threat and they went on ant lockdown.
Oh my gosh.
They changed their behavior to become much less connected, and this effectively quarantined the queen, and it limited the spread of disease. So this shows us that even in very social creatures, these connections aren't permanent, and they can break those connections when they need to.
We can learn something from the ants. We need to adapt when there is a threat.
Yes.
Okay, so this next one, I'm trying so hard to understand, Merritt, but it's hard. We're talking about quantum physics. So Einstein's theories around entanglement. This is a theory in quantum physics. Apparently he was wrong, but they use video games to prove this?
That's right. So we are talking about quantum mechanics here. So entanglement refers to when particles can simultaneously influence one another. They can become entangled even when they're separated by very large distances.
The butterfly effect is kind of on
so
that?
It's one outcome. And Einstein thought this kind of behavior was impossible. He even referred to it as spooky action at a distance. So 10,000 video game players are now trying to prove whether Einstein was right or not. So scientists basically needed to generate a truly random data set to test aspects of entanglement. And these are hard data to come by. And the video game was just a facade. It was, to make it sort of interesting for the gamers to smash buttons randomly as they moved through the game. These data were then transmitted to labs all around the world that were conducting independent experiments. And after all that effort, it turns out that Einstein was wrong. Entanglement does exist, and particles can influence each other simultaneously, even at a distance. It just took a fresh approach to figure it out.
It took video games. Merritt, thanks so much for being here.
Thank you.